Hi, Michael. So it's an exercise two in your first sheet. So actually, we have given a ciphertext, okay, and we have also given a Fi. Fi means the relative frequency of English letters. Frequency of English letters means that in English which one letter appear how many times. So it's a pre-calculated table in which the frequency of all the letters are given. Like this is for the letter A, it's a frequency. It's a letter B, C, D up to Z. So we have given this. Okay, we have already given a formula, a correlation score, which we can calculate through this equation. And remember that in this assignment, we didn't have provided the shift, that you have to shift a value by how many numbers, because it's a Caesar cipher. So in a Caesar cipher, we have to shift a letter backward to some number. Like by default in a Caesar cipher, the shift value is 3, but in this case the shift value is unknown. So for the unknown shift value, we have to find out the right shift value. After that, we will apply that shift to this ciphertext, and then we will be able to convert this ciphertext into the plain text. So we need to calculate the shift. It's represented by K, and we also need to calculate the Cj, that is the relative frequency of letters in ciphertext. Like we have given this ciphertext, so which one letter appears how many times. So this is called Cj, means relative frequency of letters in ciphertext. Okay, so we need to find out these two values. After that, we will put these two values in this equation, and we will calculate the score. So remember that we will consider the highest score, means if the score, if we calculate the score from 0 to 25, because we have a total 26 letters. So first we will take a shift of 0. So we will put the value of k as 0, and we will solve this equation. So we will have a score for k is equal to 0. After that, we will calculate the score for k equal to 1. Then for k equal to 2, 3, 4, 5, up to 25, we will calculate the score values. Then among all these 26 scores, we will pick up the one which have a highest score value, and that will be actually our shift value, that we can apply on our ciphertext, that will convert it into the plain text. Okay, so now let's see. First of all, we have to compute letter frequencies in the ciphertext. Like we need to calculate the CJ. So we will count the total letters in our ciphertext above. So if you count these cipher letters in the ciphertext, so it's total 816. Okay, and we will find out now each letter frequency in the ciphertext. So first of all, we will take A. So if you count the occurrence of A in the ciphertext, so it will you will get a value 31. Okay, so now it's a C0, means the first letter. 0 represent A. Okay, because you know that here we have A plus I. So a, a plus I means the position of the letter. So if we write down A plus 0, so on a 0 position you will have a letter A. If you increase A plus 1, if I becomes 1, so a plus 1 means one position further than a, so you will get b. And if you write down a plus 2, so it means c. A plus 3, it will be a, it means d. So by this way you can find out other letters. So here c0 means ciphertext, okay, at location 0. So how we will find out the frequency? So total occurrence is 31. 31 is divided by 816, the total number of letters. So you will get a frequency of this, like that. Okay. So at the sorry, I think it's repeated. I will remove this. Yeah. Okay. So it's the relative frequency of the ciphertext A. Then similarly for B. So B, how many times it occurs in the ciphertext? So it's 26 times. How we will compute? So it's B. B means now it's A plus I. So that's why I, the value of I or j, it's 1. So 26 divided by 816, you will get this value. It's again, so it's repeated. So by this way, you will calculate all the letters that is that you can see in the ciphertext one by one, and you will get the relative frequency of the ciphertext, because we need it here. Okay, we need here it's a c I plus k mod 26 into it's a product of the fi and the c j actually. So we will find out for example c0. So you will multiply this value to the fi is this one, if it is 0. Okay, so by this way you can calculate all the values. After that you will have to compute the correlation scores, as I told you. For a shift value of 0, so the score, it becomes like this. For 1 you will get the score, for 2 3 up to so on. So in this case, if you find out from 0 to 25, so in all these scores, you will get a shift k equal to 13, which have the highest score value, that is 0.06407. It's the highest if you find out one by one, since you will do it by hand, so it will take time. That's why I didn't compute the rest one, but I find out that the highest score is on the shift 13. It means that we will shift each letter in the ciphertext back 13 letters. Then you will get uh, the exact way. Like in the ciphertext, the first letter is S. If you shift the S 13 letters back, so you will get the value F. Okay, so you can also see that S is 13. The difference between F and S is 13. Similarly, again in the ciphertext E, you will replace this E by a letter which is 13 letters back from it. So you will find out it's R. Then similarly for R, you will get E by this one. Okay, so now you got a meaningful word frequency. It means that our guess 13 is means it makes sound. Similarly, when you apply it on a whole uh, ciphertext, so you will get the plain text as this. Frequency analysis is a fundamental, so it's a complete, you can say, plain text. So this is the solution of the example 2. So now you can answer all the values that shift value you have taken, which is the highest score. So the highest score is actually on shift 13, that is 0.06, and then you have decrypted the ciphertext by this one. Okay, so this is the solution of the exercise number 2. I hope you will understand it. If you have any confusion, so you can ask, please. Thank you.